Hi dear students, welcome back to BS Academy. We are going to discuss the third case of the image formation of the concave mirror. So for that we are drawing the concave mirror like this. This is the faded part of the concave mirror, and this point is represented as P, that is pole, and this point is represented as C, that is center of curvature, and this is the line which is joining the center of curvature and the pole, that is principal axis, and this point is represented as F, that is principal focus. Now in previous case, that is in second case, we discussed that where the image will be formed when the object is placed beyond C. Now in this third case, we are going to discuss what happens to the position of the image when the object is placed at C. So it means what we are doing, students, we are still moving the object from the previous position to the new position. So initially in the first case we placed the object at infinite, and in second case we placed the object beyond C, and in this case, that is in third case, we are going to place the object at C. It means we are moving the object from infinite towards the mirror. So from infinite distance we are moving the object towards the mirror and we are placing at C. So now in third case, imagine that the object is placed at the center of curvature, that is C. We know the position of the object is represented by the upward arrow mark. So this is the object. You can represent it as AB. Now we are going to find where the image will be formed. So now for that we have to draw the ray diagram. No? Right, see. Consider one of the incident ray emitting from the object is moving like this. It means this is the incident ray. One of the incident ray. See, this incident ray is parallel to the principal axis. So what happens according to the first rule, we know that after reflection, the reflected ray should passes through the principal focus like this. So this is the reflected ray. Is it clear, student? So we are applying the first rule. So when the incident ray is parallel to the principal axis, the reflected ray should passes through the focus. Right? Now see the second rule. We are applying the second rule. Now consider one of the incident ray emerging from the object is passing through the focus. So this is the incident ray passing through the principal focus. So according to the second rule, what happens when the incident ray passes through the principal focus? The reflected ray it will becomes parallel, right? So it has to pass like this. So it becomes parallel to the principal axis like this, right? So if this is the incident ray passing through the focus, then after reflection, this reflected ray becomes parallel to the principal axis like this. Okay, so this is the reflected ray. We know we have to find the position of the image now. So for that what we have to do, we have to find the point where the reflected rays meet. So this is one of the reflected ray and this is another reflected ray. So this reflected ray and this reflected ray are meeting at this particular point. Okay. So this is the point where the image is formed. So to find the position of the image, we have to draw the perpendicular line from the principal axis towards downward. So you have to represent it as downward arrow mark, and you can represent it as A dash B dash. Okay. So this is the third case. Is it clear, children? So what we are doing, we are placing the object at the center of curvature, and when the incident ray is parallel to the principal axis, it passes through the focus, first rule. And according to the second rule, when the incident ray passes through the focus, then the reflected ray becomes parallel to the principal axis. And these two reflected rays are meeting at a particular point, and in that particular point the image will be formed. So if the object is placed at the center of curvature, note down this point student, this is very much important. See, when the object is placed at the center of curvature, the image is also formed at the center of curvature. Okay, so we can write the position of the object. So what is the position of the object? Object is placed at the center of curvature, that is at C. And what is the position of the image? Image is also formed at the center of curvature itself. So the image is formed at C. And what will be the nature of the image? See, if you place the screen over here, you can able to see the object on the screen. So it means what? When the image is formed on the screen, then that image is called as what? A real image. And also we will see the image in the inverted position. So therefore the nature of the image is real and inverted. Okay, then what will be the size of the image? See, in this diagram, see, we can able to identify that the size of the object, that is this arrow mark, size of this arrow mark is same as the size of this arrow mark. It means this upward arrow mark represents the object and the downward arrow mark represents the image. So it means what? Whenever the object is placed at the center of curvature, the size of the image will be same as the size of the object. Okay, so size of the image is same size. It is same size as the object. Okay, it is same sized object. Is it clear, children? So this is the third case. Is it clear? So let me explain once again. See, the position of the object is at C. It means the object is placed at the center of curvature. So what happens? The image is also formed at the center of curvature itself. Okay, be clear about the ray diagrams. And what will be the nature of the image? See, real and inverted. It means we can obtain the image on the screen and also the image is inverted. Therefore, the nature of the image is real and inverted. And the size of the image will be same size. So only in this case, that is only when the object is placed at the center of curvature, the image will also be formed at the center of curvature itself, and also the image will be of the same size. It means the size of the image will be equal to the size of the object. Is it clear, children? So this is the third case of the image formation of the concave mirror. If this video is useful to you, please subscribe the channel, and if you have any doubt, you can text in the comment section. Thank you.